Hello everybody and welcome to our first lesson in Unit 3, Quadratic Functions. Our objectives for today are we will graph quadratic functions using a transformational approach and identify function characteristics. So let's get started. Just like the absolute value functions, also the quadratic functions have a parent function, which in this case has the equation f of x is equal to x squared. Now let's go ahead and graph the curve of our parent function, and we're going to do that by creating a table of values, finding a few x values and the corresponding f of x values, in other words the corresponding y values. I'm going to use -2, -1, 0, 1, and 2 for the x values, and then we get -2 squared, which is +4, -1 squared is 1, 0, 1, and 4. Plotting those points on my coordinate plane, 1 is at the origin, then I go over to the right 1, up 1, to the right 2, up 4, and equally to the left, to -1 and +1, -2 and +4. Connecting my points, I get this nice little curve. Don't forget your arrows, which you already know from Algebra 1 that it's called parabola. The curve of any quadratic function is a parabola. So let's look at our parabola and find some of our characteristics. Similarly to the absolute value functions, quadratic functions also always have a vertex. In this case, the vertex is at the origin and it has the coordinates 0 and 0. Let's think about our domain. Looking at our two arrows, the one that points to the left and the one that points to the right, we can say that our domain is x is an element of the real numbers. In other words, any element, all real numbers. The range, however, is not all real numbers. Coming from below, we see that the first value that's actually on our curve is 0, so the range is 0, which is part of it, therefore brackets, all the way up to infinity, positive infinity. And you remember, of course, that for infinity, both positive and negative, we can never use brackets, only parentheses. The end behavior, as x goes to negative infinity, in other words on the left, f of x goes to positive infinity, in other words it goes up, and as x goes to positive infinity, so towards the right, f of x also actually goes to positive infinity. It goes up on both ends. So therefore the increasing interval starts at 0 and goes to positive infinity. Let me use a different color for that, and that is this part. Right, this is where the values go up. And our decreasing interval comes from here, so from negative infinity to 0. X-intercepts, we only have the one which is at the origin, 0, 0. And remember what we said in an earlier lesson, whenever one of the intercepts is at the origin, then that is also automatically the other intercept. Both x and y intercepts are at 0. So let's talk about vertex form. This is one of the three forms that we can write in a quadratic equation in, and the advantages of the vertex form are that it'll give us information about the vertex and the dilation of the parabola right from the equation. And this is how the equation goes. F of x is equal to a times parentheses x minus h squared plus k. And you already know a, h, and k from our absolute value equations and functions. A is the dilation. We also call it slope, but it's really the dilation of our curve. In other words, is it squeezed or is it stretched? It's also what you could call it. H is the horizontal shift. In other words, left or right. And K is the vertical shift. And that, of course, means up or down. So let's look at an example on how we can use this. Y is equal to negative of x minus 1 squared plus 4. And first off, the negative already indicates to us that A is going to be negative 1. And that means two things. It means that our parabola is going to be flipped downwards because of the negative sign. But in terms of dilation, it's going to have the same shape as the parent function. Our vertex is going to be at 1 and 4. Remember, for our horizontal, we always take the opposite sign of what's in parentheses. A y-intercept we can find out by just setting x equal to 0. Then we get negative 0 minus 1 squared plus 4. So in our parentheses we got negative 1, which we're squaring. It becomes positive, but then the negative sign on the outside makes it negative again. Negative 1 plus 4 is 3. So our y-intercept therefore is 0, 3. Now, before we find any more of the characteristics, let's go ahead and graph our parabola, which we have already enough information for to do. The vertex is at positive 1, positive 4. And we said, since the dilation is negative 1, we're going to flip our curve down. So instead of going 1 to the right and 1 up, we're going to go 1 to the right, 1 down. Next over is 2 to the right, 4 down. And on the left, we're going to do the same thing. 1 to the left, 1 down. 2 to the left, 4 down. Remember, the dilation is the same, so we take the same steps as from our parent function. And we can now go ahead and already sketch our curve. The y-intercept we had found is at 0, 3, and that's exactly what the first point to the left also indicated to us. And now we're also in a good position to find our roots, because our roots are, I can hear you, the same as the x-intercepts, the solutions, and the zeros, right? So we have two roots. One is at negative 1, 0, and the other one is at 3, 0. Our domain is, and it always is, all real numbers. And for the symbol for the real numbers, always remember to give it 2 vertical bars. All number systems carry capital letters with 2 vertical bars. The range is not all real numbers. We start at negative infinity and we go up all the way to positive 4. And that is part of our range. Let me also show you something that's called the axis of symmetry. And the axis of symmetry is, now that you can see your parabola, is a vertical axis that goes through your vertex, and it's the line on which you can see that one side of the parabola is reflected to the other both ways, and the axis of symmetry has the equation x is equal to 1. It is a vertical line, that's why the equation is x is equal to, and the number is always the x value of your vertex. Let's talk about end behavior. As x goes to negative infinity, we always come from the left. F of x also goes to negative infinity, the arrow is pointing down. And as x goes to positive infinity, f of x once again goes to negative infinity. Think about this for a second. The parabola, thinking about the way it looks, our end behavior, our y values will always go in the same direction, no matter whether x goes towards positive infinity or negative infinity. F of x will always either both times go up to positive infinity or both times go down. Think about that, keep that in mind. All right, so let's find our increasing interval. The increasing interval is this time on the left. All this part is the increasing interval. In other words, from negative infinity to positive 1. And the decreasing interval goes from there, from positive 1 all the way to positive infinity. Alright, this concludes the first part of our video. Now go ahead and watch the second part.